Hello YouTube, and today I am going to be doing chapter 8 of the LFS book. So last time we backed up the system, and what did we do last time exactly? Yeah, we entering the chroot and building additional temporary tools. So this ended up with us basically setting up the chroot, mounting some virtual file systems, and basically doing a backup how far we got. Also, I was running out of disk space, so I've uninstalled some bits and pieces from this VM. And and I had to reboot and set stuff back up. So this is not exactly where we left off, but we're basically set up. I think we're set up where we were before. So the next thing that we're going to be doing is this chapter 8. So it says building the LFS system, and I'm not going to lie, I've been procrastinating on doing this video because it is going to be quite long, I would imagine, and I've got 2 coffees on my desk for this. So let's not waste any more time and let's get into it. So the first the first part of this is the introduction. Let's just read this. And this is where we're actually building the LFS system. So I won't read all of this. However, actually we'll just read the first bit. In this, it says, in this chapter, we'll start constructing the LFS system in earnest. The installation of software is straightforward, although in many cases, installation instructions could be made shorter and more generic. We've opted to provide the full instructions for every package to minimize possibilities for mistakes. The key to learn is what makes Linux systems work is to know what each package is used and why or the system may need it. We do not recommend using customized optimizations. These are the Gen 2 writing flags. Most of these and it has a warning here essentially about doing this. And he's basically saying additional compiler options have been tested in the book, and he can't guarantee that's going to be working. What does this say here? On the other hand, we keep optimizations enabled by the default configuration of the packages. In addition, we sometimes explicitly enable an optimized configuration provided by a package, but not enabled by default. The package maintainers already test these configurations, consider them safe. So what he's saying there, so it's not likely to break the build. Generally, the default configuration already enables O2 or O3, so the result system still runs very fast without any customized optimizations and stable at the same time. So he's basically saying don't add any own optimizations, and the few optimizations we are going to enable have been said to be safe by the people who've actually made the packages. Okay. For installation instructions, each installation page provides information about the package, including a concise description of what it contains, approximately how long it will take to build, and how much disk space is required during the build process. Following the installation instructions, there is a list of programs and libraries, along with brief descriptions that the package installs. Okay. And this is about libraries. In general, LFS editors discourage building and installing static libraries. Most static libraries have been made obsolete in modern Linux systems. In addition, Linking a static library into a program can be detrimental. If an update to the library is needed to remove a security problem, every program that uses a static library will need to be relinked with a new library. Since the use of static libraries is not always obvious, the relevant programs and procedures needed to do the linking may not even be known. That's fair enough. Procedures in this chapter remove or disable installation of most static libraries. Usually this is done by passing a disable static option to configure. In other cases, alternate means are needed. In a few cases, especially glibc and GCC, the use of static libraries remains an essential feature of the package building process. For more complete discussion on the libraries, see this link, which is the Beyond Linux from Scratch book. I don't know too much about this. I think the static lib basically gets rolled up into the package itself. But I'll have to check. I'm not a C or C++ expert. So without, let's just go on to the next page, which is package management. Package management is often a requested addition to the LFS book. A package manager tracks the installation of files, making it easy to remove and upgrade packages. He's basically talking about apt and yum and DNF and stuff like that. A good package manager will also handle the configuration files, especially to keep the user configuration when the package is reinstalled or upgraded. Before you begin to wonder, no, this section will not talk about nor recommend any particular package manager. Well, they all pretty much do the same thing. What it does is provide a roundup of the most popular techniques and how they work. Perfect package manager for you may be among these techniques. This is Linux spike shedding is the package manager stuff. As long as it works reliably, I don't really care what the package manager does. People obsess about which package managers they like. They pretty much do all the same thing. They're roughly the same commands. There's not a huge amount of difference. Some are faster than the others, some are easier, but it doesn't make a huge amount of difference. If you're doing apt-get install Firefox or DNF install Firefox, as long as it works, it doesn't. It's the rest is hairdressing. Some reasons why no package manager is mentioned in the LFS or BLFS include dealing with package management takes away your focus from the goals of these books, teaching how a Linux system is built. Yeah, it's a diversion, which is fair enough. There are multiple solutions for package management, each having its own strengths and drawbacks. Finding one solution that satisfies all audiences is difficult. And it's also, again, it's... I don't want to get into package management discussion. I just don't generally care about it. As long as it works, it works. If it doesn't, then it's an issue. Most mainline distros, it works. Oh, I should have this full screened. And upgrade issues. Right, so it goes on basically this bit goes on about upgrade issues. The package manager makes it easy to upgrade to newer versions when it's released. Yeah, because you just could update. Generally, instructions in LFS and BLFS books can be used to upgrade to newer versions. Here are some points that you should be aware of when upgrading packages, especially on a running system. If the Linux kernel needs to be upgraded, nothing else needs to be rebuilt. The system will keep working fine thanks to a well-defined interface between the kernel and user space. Specifically, Linux API headers need not be upgraded along with the kernel. You will nearly need to reboot your system to use the upgraded kernel. That's pretty standard. If glibc needs to be upgraded to a new version, some extra steps are needed to avoid breaking the system. Okay. If a package containing a shared library is updated and the name of the library changes, then any packages dynamically linked to that library must be recompiled to link against the newer library. I'm not going to read all that. So basically, if you upgrade a library, typically you need to, for it to work, for anything that depends on that library to work, you will need to also recompile those packages. That's pretty straightforward. If a package is directly linked to both old and new names of the shared library, for example, the package is linked to both libfoo.so2 and libbar.so1, while the latter links to libfoo.so3, the package may malfunction. So I used to have these errors in C# with DLLs in .NET. These were known as fuse log errors. You used to get the yellow screen of death. The same thing happens on Windows. You can add up in sort of like a library dependency hell. This could be caused by Yeah, so if you don't recompile basically everything that uses that shared library, you're going to end up with some things working, some things not working. If a package contains shared libraries updated, the name of the library doesn't change, but the version of the library file decreases, for example, you should remove the library file from the previous installed version. Otherwise, ldconfig command invoked by yourself from a command line or installation of some package will reset the symlink to point to the old library file because it seems to be a newer version. Its version number is larger. This situation may arise if you have a downgraded package or if they also change the version of scheme for library files. So for a library, wait a minute, I missed a bit there. For example, I don't want to read all of this because it's at length to you because it's something that you can do yourself. For example, the library is still named libfoo.so1, but the name of the library file has changed from libfoo.so.1.1. Oh, right. So it's basically a naming a version scheme change. Okay. If package containing shared libraries updated and the name of the library doesn't change, but severe issue, especially security vulnerability, is fixed, all running programs linked to the shared library must be restarted. The following command, run as root after the update is complete, will list which processes are using the old versions of those libraries. So there was a big debate on whether you should, in a Linux Discord the other day that won't be named, where it wasn't a big debate, but it was Fedora had a progress bar where they updated the system when you rebooted, like Windows, and people were being a bit silly about that. Generally, if you update the system, it's probably just best to reboot it. Rebooting my system takes around about 20 to 30 seconds, and most of that is watching the BIOS. The Linux system itself takes about 5 to 10 seconds to boot, and maybe a few more seconds to get desktop. If you've got a modern fast drive, it's a bit different. If you've got an older hard drive. If OpenSSH is being used to access the system and is linked to an updated library, you must rebuild the SSD service, then log out, log in again, and run the preceded command again to confirm nothing is still used in deleted libraries. Okay. If an executable program or shared library is overwritten, the process using the code or data in that program and library may crash. The correct way to update a program or shared library without causing the process to crash is to remove it first and install a new version. The install command provides by call utils has already implemented this, and most packages that use the command to install binary files and libraries This means that you won't be troubled by this issue most of the time. However, the install process of some packages, notably SpiderMonkey, I'm not sure what that is, in BLFS, just overwrites the file if it exists. SpiderMonkey, I think, is the JavaScript runtime for Firefox, but I could be wrong. SpiderMonkey? SpiderMonkey Linux. Yeah, it's the WebAssembly engine, okay. JavaScript. Just overwrites the file if it exists. This causes a crash, so it's safe to save your work and close unneeded running process before updating the package. This is why it's just easier to reboot the system, because it's been a lot of the time, because you basically all the processes are shut down and then there's restarted again by the action of rebooting. You don't have to, you can do all this, but sometimes it's easy to reboot. This is quite long and something that package management techniques. The following are some common package management techniques. Before making a decision on a package manager, do some research on various techniques, particularly the drawbacks of each particular scheme. Remembering everything, I won't want to do that. There's hundreds of them. Installing separate directories. Yeah, this is installing separate directories is basically what you used to do. For package managers were widespread in most programming languages. So before, in the bad old days, you would have to, this is when I was doing VB and C#, I would I'll have like a libs directory, and I'll manually copy DLLs into a directory. This is pretty much the same thing, but for C++. For example, package foo is installed in foo11, and symlink is made from opfoo to opfoo11. When a new version of foo 1.2 comes along, it is installed to that. The previous symlink is replaced by a symlink to the new version. Okay. Environment variables such as path, man path, info path, Pkgconf path, CPP flags, and LD flags in the configuration file etcld.so.conf may need to be expanded to include the corresponding directories of opfoo-x.y. The scheme is used by the BLFS book to install some very large packages to make it easier to upgrade them. If you install more than a few packages, this scheme becomes unmanageable, and some packages, for example, Linux API headers and glibc, may not work well with the scheme. Never use this scheme system-wide. Okay, yeah. I've always used it. I use this sort of something similar, as I previously said, with old C# code bases and VB code bases. Symlink style package management. This is a variation of the previous package management technique. Each package is installed as the previous scheme. But instead of making a symlink via generic package name, each file is symlinked into the USR hierarchy. This removes the need to expand the environment variables. Though the symlinks can be created by the user, many package managers use this approach and automate the creation of the symlinks. A few popular ones include Stow, ePackage, Graft, and Depot. This removes the need to expand the environment. The installation script needs to be full so the package manager thinks it's installed in /USR, though in reality it's installed in the USR package hierarchy. Installing this manner is not usually a trivial task. For example, suppose you're installing package lib4 1.1. The following instructions may not install the package properly. The installation will work, but the dependent packages may not link to lib4 as you would expect. If you compile a package that links against lib4, you may notice it's linked against this path, which I'm not going to read out. Instead of that one, as you expect, the correct approach is use the Zstd variable to direct the installation. Right, okay, so it's the prefix option which is different, so you swap them around. Okay. Most packages support this approach, but there's some which do not. For non-compliant packages, you may either need to install the package manager or may find it's easier to install some problematic packages in timestamp based. In this technique, a file is timestamped before the installation of the package. After the installation, a simple use of the find command with the appropriate options can generate a log of all the files installed after the timestamp file was created. A package manager that uses this approach is install log. Though this scheme has the advantage of being simple, it has two drawbacks. If during installation the files are installed with any timestamp other than the current time, those files will not be tracked by the package manager. Yeah, I don't like this. Also, the scheme can be used when packages are installed one at a time. Can only be used when the packages are installed one at a time. The logs are not reliable if two packages are installed simultaneously from two different consoles. Right, yeah, anything that's time-based and uses time.now, anybody who's needed the right software test for this, it's this is a similar problem. If the current time is different, and this won't work. Tracing installation scripts. In this approach, commands that the installation scripts perform as recorded. There are two techniques one can use. The LD preload environment variable can be set to point to a library to be preloaded before installation. During installation, this library tracks the packages that are being installed by attaching itself to various executables such as copy, install, move, and tracking system calls that modify the file system. For this approach to work, all executables need to be dynamically linked without SUID or SGID bit. Preloaded libraries may cause some unwanted side effects during installation. Therefore, it's a good idea to perform some tests to ensure that the package manager does not break anything and installs all appropriate files. Creating package archives. In this scheme, the package installation is faked into a separate tree as previously described in the Symlink style package management section. After the installation, a package archive is created using the install files. This archive is then used to install the package on the local machine or even on other machines. And this is basically what most distros do. I have never heard of this ever used, and I've been using Linux on and off for quite a while. This is I've seen used, but not in Linux. Maybe in Slackware. It's been years since I used Slackware. This approach is used by most package managers found in commercial distributions. Examples of package managers approach are RPM, package utils, Attr, and GNT's portage system. A hint describing how to adopt this style of package management for LFS systems is located at. Yeah, so Arch Linux also uses fake root. When I've built the odd package for Arch Linux. Creating package files that include dependency information is complex and beyond the scope of LFS. Yeah, it's its own thing, really. Yeah, Slackware uses a tar-based system for package archivers. Oh, right, so I was wrong that used the other ones. as I said, it's been years since I used Slackware. I think I tried it out when it was Slackware 8. I think they're on 14 now, and the releases are very slow. This system purposely does not handle package dependencies as more complex package management do. The details of Slackware package management, see that I'm not going to look at that now. This scheme, so user-based management, this scheme unique to LFS, developed by Matthias Benkman and is available in the Hints project. I'll open that up. I'm not going to read it now, though. In this scheme, each package is installed as a separate user into standard locations. Files belonging to a package are easily identified by checking the user ID. Features shortcomings approach are too complex. That sounds like a nightmare. You'll have hundreds of users, wouldn't you? Right, and this last bit is deploying LFS on multiple systems. One of the advantages of an LFS system is there's no files that depend on the position of files on the disk system. Cloning an LFS build to another computer with the same architecture as the base system is simple as using tar on an LFS partition. It contains the root directory, about 900 megabytes of uncompressed or basic LFS build. Copying that file via network transfer and expanding it. Copying it onto the new system and expanding it. After that, a few configuration files will have to be changed. Configuration files that need to be uploaded include, there's a list of them here. Password hosts, networking, the fstab, stuff like that. Custom kernel mainly be needed for the new system, depending on differences in system hardware and the original kernel configuration. Finally, the new system has to be made bootable via section 10.4 using grub to set up the default boot process. And that's where I think I might come unstuck. But we'll see. What I've got a plan if that happens. I've got a plan to deal with that. So after all that reading, which is probably taking a good 15-20 minutes, oh my god, it's 27 minutes. We're going to go on to installing the man pages. So I'm in the chroot. So let's do this. So it says man pages 6.12. The man pages package contains over 2,400 man pages. Okay. Installation of man pages. Remove the 2 man pages for the password hashing function. Libxcrypt will provide a better version of these man pages. Okay, so let's remove that. And am I in the LFS directory? I bet I'm not. So what I'm just doing is making so in the chroot. Right, so I've done something wrong. Go back to here. So I did do this. I'm just going to exit. Right, so pretty sure I did all this, and we're going to re-enter. Right, so let's go back. Oh, I went to the wrong place. I want to go back to chapter 8. I want to go back to here. I'll do ls. Don't have a man directory. Wait a minute. I want to make sure I've mounted these directories properly before I start running stuff again. So I thought I set up properly and I'm not. I don't think. So if I go this, I don't think this is right. So how do I check the mount points? Oh. I reckon I mounted the bloody wrong partition. No, look. That's correct. So why does that not work? What I'm going to do is pause the video here because something's wrong and I need to figure out what's going on. Right, I found out what I was doing wrong. I was being stupid again, I think. So I have to span the man pages. So so I need to. This is different from the man DB. So 6.12, and then I CD into there. Yeah, there we go. There's man 3. So the confusion that I had was I thought I was supposed to be doing this on the root file system, which is obviously not correct. I made the same mistake I did, I think, in chapter 5. Well, I didn't know where to go. I needed to go to the sources. So now we're back on track. What threw me was the fact that I had to go to back into the root, and I thought I'd done something wrong there, which is I just wasn't thinking again. Which is fine. So we're back to just follow the instructions, you know, actually follow the instructions. So let's just do this. And then install the man pages by running. So this is just make. I suspect this is not really compile step. It's probably just copying stuff across, I would imagine. Right. Right. Git equals file source prevents the building system from omitting. So these options are prevents make from setting any built-in variables. The building system of the man page does not work well with built-in variables, but currently there's no way to disable them except passing the R flag explicitly via the command line. And I've already read that one. I didn't read them in order. Right, so we go back to the compilation instructions, which is you tar it, untar it, change the directory, follow the instruction, change back out the directory, which is what we're going to do. rm man pages. Yep. There we go. So if I do ls and yeah, that's fine. So that's that done. The Iana-Etc package provides data for network services and protocols. That sounds important. So we do tar xr. I think it's yep, that looks like it. So all we did was cd into there. Just put the terminal. cd into Iana. And then ls, and these look like some XML files and some other bits and pieces. Let's just have a quick look around. Okay, cat services. Right, okay, these are just... So these XML files then. A list of email address. Okay, these are just text files by the looks of it, and they're going to get copied into etc. And we're going to cd out there. We're going to RMI INR, blah blah blah. There we go, done. Now we're going to so glibc. We've built this before, but this is for the temporary system. The glibc package contains the main C library. This library provides basic routines for allocating memory, such as directories, open and close files, reading and writing, string handling, pattern matching, arithmetic, and so on. So installation of glibc. Some of the glibc program use the non-FHS file system hierarchy specification compliant VARDB directory to store their runtime data. Apply the following patch to make such programs store their runtime data into the FHS compliant locations. Now, first thing I need to do is untar it again. And yeah, tar. There we go. Actually, make sure it runs properly. cd glibc, and then we'll patch it. Okay, cool. The glibc documentation recommends building glibc in a dedicated build directory. Okay, so let's do that. Let's make the build. Don't really need to do the b just to make sure, just to print it out. It does an error, you know, it's done it right anyway. that's done. Ensuring that the LD config and SLN utilities will be installed into the USR SBin. So echo root blah blah blah. Okay, cool. So that's just setting some configuration parameters, and then we do the configure step, and yeah, so this option disables the W error option past the GCC. This okay. Enable kernels. Right, so that's basically like to flag these. It was kernels as old as 5.4. I think we've been over that in a previous video. This option increases system security by adding extra code to check for buffer overflow, such as stack smashing attacks. Note that glibc always explicitly overwrites defaults to GCC, so this option is still needed, even though we've already specified the enable default SSP for GCC. Disable NSDD. Do not build the name service cache daemon, which is no longer used. Okay. Taking a quick drink. Libc dv slibdir equals blah, blah, blah. This variable sets the correct library for all systems. We do not want lib64 to be used. Okay. So let's run this configure step. Okay, I'm not sure what this really does. And then we do make. Right, so that's built. And then we do. Oh, we're actually going to run the tests. Okay, so that's cool. That's a bit different. In this section, the test suite for glibc is considered critical. Do not skip it under any circumstances. Okay, we won't run it. I would imagine it's going to take a while, mate. Check 6,000 tests. Right, that is done. Right, so one fail. So it looks like most of these tests passed, which there are 6,000 tests. 5,671 of them passed. There was one fail. So let's just see if that one fail is this IO test LCH mod is known to fail in an LFS chroot environment. Okay. Some tests, for example, NSS test NSS files host multiple, and NPTL test thread affinity star are also probably are known to fail due to a timeout, especially when the system is relatively slow or running test suite with multiple parallel jobs. So I think that fail is that. Which one? Let's just. Can I keep on scrolling up? Yeah, so that failure is this one, and that is a known failure, so that's fine. Grep. So let's run this grep. Oops, fat fingered it. Let's do. There we go. Yeah, this is. We don't seem to have any of those. Where do these tests live? I'm not sure if that's actually doing anything correctly. I'm not going to worry about it because we don't have a relatively low system and these 16 failed. So let's just check whether these failed. So unsupported. Unsupported means they're probably not relevant. Unsupported, fail, unsupported. NSS, what's it? This host and test thread affinity. No, I think this is fine. I'm just doing a spot check. There's no point in. I don't think there's any point in me going at length through this because I suspect that this is all okay by the looks of it. The thing that has failed is what is expected to be failed, which is exactly what the book says. Most of the past, I'm not sure what a 16x fail is. So what's x fail mean? Is it in here? So this is a test may fail with relatively old CPU models. Okay. I read that bit. Don't care about this warning. We'll just do that anyway. Okay. Right, so to fix a make fail, skip an outdated sanity check that fails with a modern glibc configuration. So okay. That's I'm not upgrading glibc. I'm not going to read this. If I ever update this installation, I suspect if I revisit any of this, it'll be automated. So because I don't want to go through doing all this manually ever again. So let's just do make install. Right, and then it says fix a hard-coded path. So this looks like it just changes a value in a file somewhere. Okay, that's fine. Run that. Next, install the locales that can make the system respond in a different language. None of these locales are required, but some of them missing. The test suites of some packages will skip important test cases. Okay. Individual locales can be installed using the locale def program, e.g. the second locale def command below combines the, I don't know what, char set independent local, char set, I'm not even sure what that is, definition with the, some of this always sounds like nonsense. Char set, this one combines this with that, and appends the result to the locale archive. The following instructions will install the minimum set of locales necessary for the optimal coverage of tests. So, e.g. the second locale def command below. Okay. Oh, right. Okay, I see what it's saying now. So what it does is it just combines them all into a file. Okay. So we're just going to run this. We've got E and GB in there, so that's good. That's the correct one. In addition, install the locale, your own country, language, and character set. Alternatively, install all the locales listed in glibc 2.41 locale data supported file. It includes every locale listed above and more at once with the following time-consuming command. Why not? Let's do it. Right, that seems to have finished. So then it says, then use the locale def command to create and install locales not listed in the glibc 2.41 locale data supported file when you need them. For example, the following locales are needed for some tests later on in this chapter. Okay. So do I need to run this or don't I need to run this? Then use the locale. Okay. We'll run this because it says it's needed later on this chapter. So let's just run it. Sometimes it's a little bit frustrating because what I want it to tell me exactly what I'm supposed to be doing. Not like, oh, if you need this, well, just assume everybody's using US English or just English because things written in English. Not reading that. Configuring glibc, adding the NSS switch config. The etc NSS switch config file needs to be created because the glibc defaults do not work well in a networked environment. Create a new file, etc NSS switch conf by running the following. So let's just run that. Right, install and set up the time zone data with the following. Okay. So what does this do? This is the Zstd data. You do something similar in Arch Linux. I'm pretty sure if you're doing a manual install. Though it's been years since I've done that. Zone info, yeah, there's a directory with all the zone info. Both the zone POSIX. Okay, so this makes some directories. So this loops through here. And zip. So what does that do? Zip. Right, so it compiles the time zones, okay. And then it copies these files into this directory here, by the looks of it. Yep. And it does something special for New York, and then it unsets this variable, okay. So we go back to here. Sorry, here. We want to be in this one. And then what we do is we're just going to run that. That looks like it ran okay. And we're finally onto got past glibc. Brilliant. So installation of ZLib. So first thing we need to do is cd out up here. So this is cd twice. And then we do rm -rf glibc. Right, it's done. And pair ZLib. So we first need to make this a little bit bigger, I think. It's a little bit easier to see. So rxf ZLib cd ZLib make. Oh, didn't configure it. Well, it's nice of it to tell me. There we go, and make. Make check. Okay, cool. That was a lot shorter than last time. Make install. Right, done. And remove the useless static library. Okay, we'll remove that. Yep. So so we cd out there, rm -rf zlib. It'll go to bunzip. The Bzip 2 package contains programs for compressing decompressing files. Yep. Okay. So this is going to be another quick one. Apply a patch. So again, let's just clear the screen. It's tar xf bzip bzip 1.8. Yeah. Yeah. So cd into bzip, and then we run the patch. And following commands ensures installation of symbolics that links are relative. Okay. So we run that. It's just edits the text file, it just edits the matrix file by the looks of it. Ensure the man package is the man pages are installed into the correct location. Prepare Bzip2 for compilation with this. Okay, so we. Okay. Meaning of the make parameter. This will cause Bzip2 to be built using a different makefile. In this case, makefile blah blah blah. So this is just saying use this makefile, which creates a dynamic libbz2.so direct library and links to the Bzip2 utilities against it. So okay. And then we do make clean, and then make, and then we run make install. Sorry, install the programs. Okay, install the shared library. Okay, so we just copy the library across, and then we symlink it by the looks of it. Install the shared Bzip2 binary into the USR bin directory and replace 2 copies of Bzip2 with symlinks. Okay. Install the. I should have just copied the whole script there. Really matter too much. Remove the use of static library. Okay. Right. And so we now do xz. CD out of here. RM. RF. Then zip. 1.0. Blah 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 blah. And installation of xz. So we need to tar xf. Let's just clear the screen first. Oh, it's the xz, blah blah blah. So we cd to xz, and then we configure. And then we do make check. Oh, this has got nicer. All of them pass, which is good. And then make install. So that was very simple. I like that one. RFXZ, blah, blah, blah. Yep. And then we make the. Well, what was XE again? Yeah, so it's just another compression utility. So this is a lossless compression algorithm, and it's apparently very fast. So again, we clear the screen, we tar xf. And then we cd into Lz4 build. So this is pretty much self-explanatory. Don't make a static package, and do the prefix. And then we run this test. And then install the package. Okay. Done. So cd out there with RMF. Lz4. Blah, blah, blah. Right. Another real-time compression algorithm. So this is Zstd. Not sure what this does. Well, I do know what it does because it says that it's a real-time compression algorithm. I'm sure this is. What's the difference? Well, being backed by a faster decoder. Okay. Not sure why there's two, but there must be a good reason for it. And make prefix. So we see here, so it's basically always saying you tar into, you basically extract it, cd into it, and just run the commands. Basically, it's not particularly difficult. And we do the make step. So this says to compile the package, run make prefix USR. Right, let's just do that. Boom. That will take, hopefully won't take too long. Got like a short approximate build time is 0.4 SBU, so it should be quite quick. And then make check. So I'm more interested in getting, while this is doing its bits and pieces, the reason I sound a bit, you know, this is not for me. This is very mechanical, and while it's necessary, I do find it a little bit tedious running all of this to test the results, because this is kind of what I do for a job, is build stuff and test it, and it's, you know, this feels like work. Which one did I? So let's make check. So all tests complete successfully. So that's good. Test run, and we install the package. There we go. Remove the static library. Boom. So we cd out there. We rm minus rf zstd blah blah blah. And then we compile file. So we tar xf file. We do the configure step. So we cd, clear the screen, cd into file. We run the configure script. And then we do make check, and then make goal. Right, and we cd out there. We rm minus rf. What was it? File we was building. And then we have to do readline. Readline. So just so you know, the file package, we compiled this before. This is why I'm skipping some of them. File package contains a utility for determining the type of a given file or files. That's all it does. Readline package is set libraries, and this is the readline. We're going to compile that next. Is a set of libraries that offer command line editing and history capabilities. Okay. Installation of readline. Now this is going to be a little bit more complicated. So the first thing we need to do is always tar xf readline, and reinstalling readline will cause the old libraries to be moved to library name old. While this is normally not a problem, it causes, in some cases, it could trigger a linking bug in LD config. This can be avoided by issuing the following two sets. Okay, well, we'll run that. Oh, I'm not in the readline. So let's just copy that in again. Done. Prevent hard coding library search paths rpath into the shared libraries. Package does not need rpath for an installation into a standard location, and rpath may sometimes cause unwanted effects or even security issues. Okay, well, we should probably get rid of that then. There we go. We run a configure script. And basically, the only command line option there that's like new is with curses. The option tells readline that it can find the term cap library functions in the curses library, not a separate term cap library. This will generate the correct readline.pc file. Now, PC, I think, is a file that lets you find where readline is. I think this is what I remember from CMake. This is like CMake sees all this stuff as kind of legacy. Whether that's correct or not, I don't know. And then compile the package. Okay, let's compile it. The option forces, so this option here basically basically forces this to use the libcurses W library. I think whenever it's W, I think it's the internationalization version, but I'm probably wrong. I've seen that from the C++ stuff libraries. Sorry, reference. There's a C. Just to be more clear, there's a C++ library online. So reference, I should say, online. And whenever you see wchar, I think that's the internationalization version. But again, I'm not a C++ expert. That could be completely wrong. This is just off the top of my head. This package does not come with a test suite. Okay, fine. And then if desired, install the documentation. Yeah, we should probably do that. Boom, doc's done. So cd out here, rm -rf, readline, clear the screen, and then we do M4. This is the macro processor, so we've compiled this before. It's M4. I wonder if there was an M3 and an M2. I suspect there was. Oh, I need to do cd into it. I'm getting lazy. And then we do the configure step. Right, and then we do make check, run the tests. Same thing going to be the most of these packages. So again, this is like last couple of videos where skipped a few tests. That's all good. That's all pretty standard. Done. Yeah, skip. So most of them, all of them that ran past, and then skip some tests. And then we're going to do make install. Oh, done. So that's M4 done. And cd out of here, rm -rf. Can't type. And so we're going to compile BC now. The BC package contains arbitrary precision numeric processing language. I don't know what that means. But it's here for a reason, so that we're going to build it. So clear the screen. BC. So what this is saying is the C compiler is GCC, run the configure step, looks fit with the prefix, and with these optimizations, so 03, the parameters, this specifies the compiler to use, emits part of the test suite that won't work until the BC program is installed, specify the optimization to use, enable the read line to improve the editing feature of BC. Okay, we run that. Oh, not CD, forget the CD into it. Right, and then we do make test. Right, that done. So we cd out of here, rm -rf, bc, blah blah blah. There we go. And then we're storing flex. The Flex package contains a utility for generating programs that recognize patterns in text. Okay. So tar xf flex. There we go. CD flex. Kept on forgetting to do that. And then we again this is a standard configure step. Some options. Make check. All of those pass, that's good. No problems there. Make install work. Right, so a few programs do not know about Flex yet and try to run its predecessor Lex. To support these programs, create a symbolic link named Lex that runs Flex in Lex emulation mode and also creates a man page of Lex as a symlink. Okay, so this is going to symlink some stuff, and that's about it. Done. So CD out there, rm minus rf Flex. Done. Now we're on Tcl. I had a job interview about this once upon a time. A company did this. I just wasn't interested in it. So the Tcl package contains a tool command language, a robust general purpose scripting language. The expect package is written in Tcl, pronounced tickle. Oh, seriously, I'm not saying tickle. Installation of Tcl package, and the next two, expect and Deja GNU are in. Who comes up with these names? Who comes up with these names? These terrible names. They're just absolutely awful to pronounce. Are installed to support running test suites for Binutils, DCC, and other packages. Installing free packages for testing purposes may seem excessive, but it is very reassuring, if not essential, to know that most important tools are working properly. Right, so we need to first, I'm not saying tickle, and then we go into Tcl. Right. What? Right. Prepare. Right. So source state equals. Okay. So what this does is it sets the source directory to the current working directory, which it should be this one. Then we cd to Unix, and there's a Unix folder by the looks of it. And then we configure that stage. So that's what we're going to be doing. I think meaning the new configure parameters, we've gone over this, I'm sure. So this parameter prevents hard-coded library search path, rpath, in the binary executables and shared libraries. The package does not need rpath for installation into standard location. The rpath may sometimes cause unwanted effects or even security issues. Yeah, I'm sure that was one in the previous packages. Build a package. Okay. It said some files, and then unsets a directory. Right, so it just make patches a load of files by the looks of it. It looks like it just replaces. yeah, the various set instructions after the make command removes references to the build directory from the configuration files and replace them with the install directory. This is not mandatory for the remainder of LFS, but may be needed if a package is built later uses TCL. Okay, well, we should run that. Right, so that's the make done, and then we do make test. Right, failed 0, so passed. There's a lot of tests that are passed. There was a lot of tests that were skipped. I suspect it was like I saw a Mac OS test, and that's probably not relevant. So that looks like it's good. And then we do make install. Right. Make the install library writable so debugging symbols can be removed later. Okay. Install TCL headers. The next package expect requires them. Okay. Now make a symbolic link. Okay. Done. Okay. We'll just this is just renaming packages. Sorry, renaming a man page. Yeah, optionally install the documentation by issuing the following command. So we cd and that was that document HTML doc, and then it makes a doc directory in shared. Right, okay, this is, and it just copies a load of files across. That's all that does. So that's worked. CD out there, rm -rf tcl 8s6. Right. And now we do expect. This is going to be short. The expect package contains tools for automating via scripting dialogues, interactive applications such as Telnet, FTP, Password, Fusk, rlogon, and Tip. I'm not sure what Tip is. Expect is also useful for testing these same applications as well as easing all sorts of tasks that are prohibitively difficult with anything else. The Deja GNU framework is written with expect. These Deja GNU sounds like a sort of like a shout from some fantasy video game. So we'll do ritual, and it's expect. So 5 blah 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 blah. Right, so that's the file. We cd into expect. Why it couldn't find that, I'm not sure. Expect needs PTYs to work. Verify that the PD files are working properly inside the root environment, performing a simple test. Okay. Okay. Command should output as okay if instead the output includes OS error out of PTY devices. The environment is not set up for proper PTY operation. You need to exit the root environment, read section. Yeah, basically you have to go through section 7.3 and 7.4 again that we did in the last video. This issue needs to be resolved before continuing on the test suites requiring expect. For example, test suites of Bash, Binutils, GCC, GDBM, and of course expect itself will fail catastrophically, and other subtile breakages might also happen. So that's okay. So we're good. Now make sure some changes. Make some changes to allow the package. Now make some changes to allow the package with GCC 4.1 and later. Right, okay. done. Configure step. Right, so with TCL, so that tells it where TCL config.sh script is loaded. So it just basically tells it where script is. And with TCL include, and that tells it where the include path is for TCL. And that's all that does. So we do that. And then make test. Right, that's done. And then make install. And then I think we need the symlink there. Right, done. And then we need to Deja GNU package contains a framework for running test suites on GNU tools. Now I know why the Primogen goes and says everything with its stupid voice, because I'm doing it now. It is written in expect, which itself uses TCL. Okay. So scripting language runs another. This is it's a scripting language on a scripting language on a scripting language, but it contains a framework. So there's a framework. It's written in a language. What was expect again? Right. So this is a library. So this is a library that's built on top of a library, which is built on top of a scripting language. Okay. I was thinking to myself, is this like three scripting languages built on top of each other? But I was being unfair. So we need to do the tar xf ritual deja GNU and make the -v build. So we need to cd the deja GNU. And then cd build. And then we run this configure script. He doesn't say what they are, but I'm not sure what this make info does. What does make info do? Man, make. Right, so all this does is go and convert these files from one format to another. That's what these steps do here. I'm not going to go through every command line option because this video is long as it is. I suspect it's going to be like 3 hours once edited. Nobody's going to watch it. Maybe there'll be one person who watches it all. I won't probably even watch it. Check. Make no rules to make check. Oh, wait a sec. I'm in the wrong terminal. It's fine. It's fine. It all failed. It's fine. Right, you need to run it in the correct terminal. So we do the configure step. And then we do make check. And then we make install. And then we set some file permissions and copy stuff over by the looks of it. So I could have just copied and pasted the whole thing. Boom. Now, package config. Yeah, I know this one. So the package config processor is the successor to Pkgconf package is a successor to -config contains tool passing, include paths and or library paths to build tools using the configure and make phrases of package installations. Now, I know this from CMake because I'm familiar with CMake. And yeah, so package config is like an older way of, well, it's older than CMake. From the CMake book, it says that everything's basically, this is all old, you should be doing everything with CMake. However, this was an update over package config. So anyway, we need to build it. So we need to get out of here. RMF dejar. Oh, we're still in the. We did CD enough times. RMF -r deja vu and tar xf package comp. Right, that's the correct one. CD package comp, and then we do configure. Right, so make install, and then right, so the reason it makes these sim links is to it basically replaces this older tools and right, okay, so it makes these, so when you go to this, when you look at the man page for this, it comes up with the man page for this because it's a replacement. Okay, so that's just right, I need to run this one. I could have just copied and pasted the whole thing, but do it the hard way, why not? And then our package comp, blah, blah, blah. And then we're going to be making Binutils again. So this is going to be CD into it. And then we're going to yeah, we're going to make the build directory. So build directory, build, let's do it properly, and then CD build. And then we do the configure step. And there's immediately the new configure parameters, enable LD default, build the original BFD linker. Now I looked this up last time, binary file descriptor linker, and install it as both the LD default linker and the LD.bfd. Okay, enable plugins. Okay, that's straightforward. Enable plugin support for the linker. Uses the installed ZLib library instead of building the included version. So we're going to use the ZLib library that we built previously. So let's run that configure step. Sorry, build with the ZLib library, I should say. Compile the package. Okay, let's just run make. Right, and it's while that's building, I'll read this out. The meaning of the make parameter. So tooldir equals USR. Normally the tooldir, the directory where the executables will be ultimately located, is set to X prefix target alias. For example, x8664 machines would expand to USR x8664 PC Linux GNU. Because this is a custom system, this target specific directory in USR is not required. Okay. I'm not reading that again. Would be used if the system were used to cross-compile. For example, compiling a package on an Intel machine that generates code that can be executed on a PowerPC machine. So this is showing its age. The reason it's showing its age is that, you know, PowerPC, when it's originally built, PowerPC chips were, you know, the still using desktops. They're typically, I think they are anymore. So test the results. So we do make a check. Right. Test suite for Binutils in this section is considered critical. Do not skip. Okay, we won't. This is going to be a horribly long video. Right, so that looked like it worked correctly by the looks of it. Well, did it? Most of them. So does it say? I think that worked. So we'll go with it that it worked. Because that hasn't printed anything out by the looks of it, which means it hasn't found anything. So that's fine. Make install and then remove the use of static libraries and other files. So this cleans up a load of gum. So this is just an RM basically. Done. So this is the GMP package. This apparently contains a load of mass libraries. So this is for precision arithmetic. I'll imagine this is important. Right, so it's got a couple of notes here. These look like they could be important. If you're building for a 32-bit x86, but you have a CPU which is capable of running 64-bit code, and you have specified C flags in the environment, the configure script will attempt to configure 64 bits and fail. Avoid this by invoking the configure command below. Right, we're not building 30. That's not relevant. The default set is the GMP produce libraries optimized for the host processor. If library suitable for processor less capable than the host CPU or desired, generic libraries can be created by appending the host none Linux GNU option to the configure command. Right. Right, so basically, if I wanted, I've got a 5950X in here. I think this will go and produce code that is optimized for that processor. According to this, and this will basically go and produce a more sort of like generic version of the library that uses doesn't use the features that are specific to my processor. I suspect that'll be how most Linux distros do it. So, however, first, before we do this, we need cd out, cd ... and then my RMF, my binutils, and then we need to tar xf gmp cd gmp, and we run the configure step. Right, so this enables CXX. It literally enables C++ support, and that specifies doc directory. There's not much too crazy going on there. Run the configure step. to make how long does this take? Not very long. Okay, so I remember saying in one of the first videos I'm going to just ignore this SBU time, and I ended up doing it. So again, this is considered a critical library and we have to run the test, so let's just do that. Now it says ensure at least 199 tests in the test suite pass. Check the results by issuing the following command. Okay. Can't copy and paste. $199. Okay, that's good. So make install.html. Done. Right, so we cd out here. Let's do this first, and then RMF GMP. Done. Right. MPFR. What's that? So this is another mass package by the looks of it. The MPFR package contains functions for multiple precision maps. Okay, I'm not sure what that is. I won't pretend to know. However, it's in here for a reason. MPFR. And then we say cd into it. And right, so again, this needs to run, and it's pretty much the same as before, so we do make check. And then we do make install, make install.html. Done. So cd out here, rm. Ooh. Do we check that? Yeah, I didn't actually check it. So MPFR, bomb, done. Let's do MPC. Right, the MPC package contains a library for arithmetic of complex numbers with arbitrary high precision and correct rounding of the result. Okay. XF MPC. I would imagine this is useful for like 3D stuff. Oh, well, would be useful for engineering stuff. Actually, not 3D stuff. So, C, PC. And then make. So this is the same again, always the same. So make check. Let's go up. That looks like that's good. There was no failures. So make install HTML. Done. Right. CD out there. RMC, MPC. Blah, 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 blah. Right. We're gonna. The Attrib package contains utilities to administer the extended attributes of the file system object. So, same procedure as always by the looks of it. And then we do configure. Oh, I didn't CD into it, being lazy. Well, I'm rushing a little bit. I want to get through this. Right, it's only 2 tests. Okay, fine. Done. Let's say CD out there. RMF. So remove the directory again, clear the screen, and then we build ACL. So the ACL package contains utilities to administer access control lists, which are used to define fine-grained, discretionary access rights for files and directories. Okay. So tar xf ACL cd ACL. We run the configure script. Make. Right, so we have one failure. However, it says here that it is test CP test is a known failure. The test CP test is no failure because core utils is not built with ACL support yet. Okay, so that's fine. Done. CD out there, RMF minus ACL, boom, done. Now, Libcap. The Libcap package implements the user space interface to the POSIX 10003.1e capabilities available in Linux kernels. Those capabilities partition the all-powerful root privilege into a set of distinct privileges. Okay, so .xf. So we prevent the. Oh, let's go. I'm not in the directory, so. Right, so all that does is it sets the library directory to usrlib rather than usrlib64. It has no effect on x86. Well, that's all that does. Okay, so make test. And then install the package. Right, so we need to CD out of here before we do anything. Ooh. RM minus RF lib cap. And then Libxcrypt. So we're just going to do rxf Libxcrypt, and then we're going to cd Libxcrypt. And we do the configure step. And while that's configuring, we'll read them out. So this is likely to be very quick, I'll imagine. So the meaning of new configure options. So enable hashes that's strong and glibc. Build strong hash algorithms recommended for security use cases and hash algorithms provided by the traditional glibc libcrypt for compatibility. Okay. Enable obsolete API. So that just disables old stuff basically. Disable failure tokens. Disable failure token feature is needed for compatibility with traditional hash libraries of some platforms, but a Linux system is based on glibc does not need it. Okay. Then we do make check. Make install. Right, so it says a note here. The instructions above disable the obsolete API functions since no package installed by compiling from sources would link against them at runtime. However, the only known binary-only applications that link against these functions require ABI version 1. If you must have such functions because of some binary-only application or to be compliant with LSB, build the package again with the following commands. Right, that's not relevant. So, shadow. So, I'm going to have a quick look how far we're through, and I think I'm probably going to stop the video here. And because it's almost 2 hours long and there's half an hour before. So what I'm going to do is I'm going to split this chapter into 2 parts probably. Yeah, I'm around about halfway through. And had to do a bit of mucking around at the start because I was basically I rebooted my machine and forgot to save this machine state because I made some more room on the machine and that threw me off a little bit. However, this is pretty much the same as the previous chapters. It's very mechanical. I think you can tell by my demeanor on the videos that or at least this video, that I find this it's a little bit boring, to be honest, a little bit tedious. I think it's just going through the steps of compiling stuff. It's very mechanical. So that's my thoughts so far on this chapter, and I'm going to leave it there. I'm going to do the rest of this chapter today after having a short break, and I'll put this up in probably 2 parts, because otherwise the video is going to be like 5 hours long at its rate. So I'll see you hopefully in the next video. Bye bye.